Samuel Morse, the telegraph. Current, electric signals, impulses that can convey human utterances almost at the speed of light. One of the great inventions of the 19th century ushered in the era of swift communication, the electric telegraph. Samuel Morse from Charlestown in the American state of Massachusetts did more than anyone to develop the electric telegraph and introduce it on a worldwide basis. Morse was an artist by profession. His portraits and historical paintings had earned him modest fame. Morse also sought artistic inspiration in Europe. On a return voyage in 1832, he heard about the electric telegraph, a new invention which from then on was to captivate him. Samuel Morse strove for 10 years to establish the world's first commercial telegraph line. He also developed the first international communication system, the Morse code. But the basic concept of telecommunication is much older than Morse's electric telegraph. Fire beacons and smoke signals on line-of-sight locations were used to convey messages as long ago as the Trojan War. In 1792, more than 2,000 years later, a fixed optical telegraph line was developed in France. It linked Paris with Lille in the north. Devised by the French engineer Claude Chappe, the semaphore system consisted of 3 simple signal elements, a beam and 2 arms. With it, Chappe was able to reproduce the entire alphabet and a number of other symbols. The Lille to Paris visual signal line included 22 towers, and it took only 2 minutes to relay a symbol along the 270-kilometre-long route. Chappe's visual telegraph was soon in great demand in Prussia as a swift communications system. With Prussian thoroughness, the number of arms was increased to 6. In 1830, this optical telegraph line linked Berlin with distant Koblenz. A few years earlier, Samuel Thomas von Simmering had used electric current for his telegraph, or, to be more exact, its chemical effect. Simmering's transmitter had a contact for each letter. At the reception point, the contact was connected to the corresponding electrode in a trough containing an electrolyte. At each of the letters that had been transmitted, current flowed, and, as a result, gas bubbles formed. In applying electricity, Simmering had been very progressive. Yet later, it wasn't the chemical, but the magnetic effect of the current that produced the breakthrough. The first electromagnetic telegraph was devised in Göttingen, Germany, by Carl Friedrich Gauss and Wilhelm Weber. In 1833, the 2 scholars operated a private telegraph line over housetops between Göttingen Observatory and the physics laboratory. They communicated via a special code they'd drawn up. A magnetic needle was deflected, left or right, according to the strength of the signal transmitted. The recipient of the message had to observe the direction of deflection through a telescope. In 1837, Carl August Steinhaus invented the needle telegraph. The movements of a magnetic needle were recorded on a paper strip. The device was a transmitter and receiver in one. This modern design principle was also used by Werner Siemens for his needle telegraph. At this time, magnetic needle telegraphs were becoming established throughout Europe. In Britain, Cook and Wheatstone even designed a fast 5-needle telegraph for the railways. But in America, Samuel Morse was still working on his first experimental model. He built a telegraph that looked very strange indeed. It was made almost entirely of components Morse had found in his studio. An old clock mechanism on an easel pulled a paper strip step by step over a small box. The pencil for recording the transmission code was attached to a wooden triangle that was moved to and fro by an electromagnet. Morse was anxious to present his invention to the general public because now he also knew how to transmit his code. He'd manufactured a set of differently shaped metal types which enabled him to depict letters and numerals as a succession of impulses. The idea was simple and effective, and Morse wanted to try it out in practice. With Morse's method, the set of type at the sending point triggered off a specific contact sequence. As soon as current flowed, the electromagnet at the reception point pulled down the pencil, which drew an angle on the paper. If the circuit was interrupted, the pencil returned to its position of rest. Each sequence of angles and straight lines represented a symbol that could be checked in a code book. In 1837, in this seminar room at New York University, Morse presented his invention for the first time. But he already had his sights set on his next goal. He wanted to be the first man to set up a telegraph line on the American continent. But it took him 6 long years to convince Congress in Washington of the usefulness of his plan and get permission to go ahead with it. In 1843, the first telegraph line in the United States was completed. It linked the capital, Washington, with Baltimore, 60 kilometers to the north. Other lines followed. By this time, Morse had improved his original development. With the new Morse key, a skillful telegraph operator could relay up to 80 characters a minute. The newly developed Morse code was a binary system. Using a sequence of dots and dashes, Morse was able to transmit every letter and numeral. Every telegraph operator had to know the Morse code. To indicate where one character stopped and the next one started, 3 spaces were always inserted between any 2 letters or numerals. The basic principle of telegraphy remained unchanged. The telegraph is a remote-controlled electromagnet. When the Morse key is pressed at the sending point, a contact is closed. As a result, the electromagnet at the receiving point raises a lever and forces a pen or pencil down onto a paper strip. Messages are transmitted as a sequence of impulses. 1 or more impulses form a character. This was the first message which Morse himself transmitted from Washington to Baltimore. The first electric telegraph line in Germany opened in 1848. It linked Hamburg with Cuxhaven. Soon, dispatches were being sent and received at newly opened telegraph offices in towns and cities all over the country. telegraph operator was a popular job. In order to improve transmission speeds, instead of waiting for machines to print out characters, operators listened to the impulses and wrote down the messages directly. Naturally, this called for tremendous concentration. One of the most gigantic undertakings in the second half of the 19th century was the laying of submarine telegraph cables. For the first time in history, worldwide communication had become possible. The telegraph company's huge underwater cables spanned thousands of kilometres. Transmission technology had been improved in two main areas. For long-distance transmission, the range and capacity of the lines had to be increased. On its own, the unamplified signal was too weak. As the distance grew, the signal was gradually submerged by the static on the line. This problem was solved by the use of amplifiers. Long-distance lines were expensive. To put them to better use, multiplex technology was developed. It enabled several signals from different sources to be transmitted down one and the same line. The multiplexer interweaves the incoming signals in the transmission line. This creates a time division signal which is amplified and transmitted. Multiplexing prevents the various signals from becoming superimposed. At the receiving point, they're restored to their original form. A new form of communication that didn't require any cables was radiotelegraphy, which appeared at the beginning of this century. It proved a particular help to shipping. For the first time, captains of vessels in distress could put out an SOS call and thus sometimes save the lives of passengers and crew. In another area, David Edward Hughes achieved a major breakthrough with his type-printing telegraph. Hughes's device transmitted and received signals not in the form of a code, but as ordinary letters which could be read by anyone. Hughes's invention came at just the right time. The age of industrialization needed a user-friendly communication system. It revolutionized the press, too. In the past, newspaper reports had often taken days to arrive. Now they could be dispatched around the world in seconds, to the benefit of readers. Telegraphy made distances shrink. The telegram, a message quickly transmitted down a wire, soon became popular for private purposes, too. At the time, it seemed inconceivable that messages could reach far-off places almost as quickly as they could the next town. But how many hands did a telegram have to pass through before it finally reached the addressee? Hughes's type-printing telegraph was a forerunner of the telex machines which dominated business communications for many years. Now they're being replaced in many offices by modern computer communications and data transfer systems. Personal computers are becoming more and more important for direct communication as well. Telephone and data networks provide access to international computer systems from almost any place on Earth. Samuel Morse, who died in 1872, rich, famous and highly respected, would be staggered if he knew what had developed from his electric telegraph.